One terrifying prediction is that by mid-century, up to 30% of adults will be affected by a form of dementia, chiefly Alzheimer's disease. This happens when proteins called beta amyloid and tau build up in the brain and damage nerve cells. But scientists think this begins to happen decades before a person develops Alzheimer's symptoms, meaning that we might have an opportunity to intervene and change the course of the condition if we can tell who's affected sufficiently early. Now, researchers at Washington University in St. Louis have discovered subtle changes in the patterns of brainwaves we produce when we sleep in people with early Alzheimer's. My name's Katie Haler, and I heard about the work from the study's author, Brendan Lucy.
We measured sleep-wake activity in older adults, 65 years and older, using several different measurement devices. The main one we were interested in was worn on the forehead and gave us a measure of their brainwave activity.
How does looking at someone's brainwaves tell you about their sleep?
We can determine what stage of sleep someone was in. There's obviously wakefulness. There's non-rapid eye movement sleep. There's 3 stages, a drowsiness and then a stage 2. Stage 3 is very deep sleep and slow wave sleep. And then the last stage of sleep is rapid eye movement sleep. Each stage of sleep is characterized by specific waveforms on the brainwave study.
So what did you find out then?
What we looked at was during non-rapid eye movement sleep, slow wave activity decreased with increased tau in the brain. Slow wave activity is thought to have an important function for memory consolidation and is a measure of good sleep quality.
So in your study participants, you saw when people weren't getting very much of this deep sleep, there was also an increase in these tau proteins, which is, as you said, a marker or hallmark of Alzheimer's.
Yeah, that's right. What I think is happening is that as the tau protein accumulates, it injures the neurons. And I think this is disrupting the networks that produce the slow waves.
Are you saying then that we know which way round the causal relationship goes? So it's the tau protein buildup that may be disrupting sleep and not the other way round?
That's one hypothesis. I wouldn't say that we have answered that question yet. Sleep and Alzheimer's disease are currently thought to have a bidirectional or two-way relationship where sleep may be a marker for Alzheimer's disease, and that's what our paper was primarily focusing on. But there's also evidence that sleep disturbances may increase your risk of Alzheimer's disease. And this study doesn't answer that question because it's what we call a cross-sectional study, meaning that all the participants had their sleep measurements done at one point in time. And we really need longitudinal studies or follow-up studies to address the question of timing.
What are you hoping that understanding this relationship could do for people with Alzheimer's?
The way that we monitor for tau and amyloid beta are either imaging studies, which are expensive, or lumbar punctures to sample that fluid around the brain, which is invasive. And if we had an additional marker that was relatively inexpensive, could be repeated many times, and was non-invasive, such as sleep monitoring, that could help inform a clinical trial as you follow the response to an intervention. Another use could potentially be to help with determining an individual's risk of developing Alzheimer's disease.
Brendan Lucy there from Washington University in St. Louis. And the study was published in Science Translational Medicine.